Get started. This video is on subtracting negative numbers. And before we talk about subtracting negative numbers, I want to set it up using everything you already know about different types of negative numbers. So with adding negative numbers, there's kind of two different problems we see. The first one is on the left in green, and that's what we do when the signs are the same. And when the signs are the same, we add the numbers, and then we give the answer the common sign. So if both add-ins are positive, we add them and give the answer a positive sign. If both add-ins are negative, we add those numbers and give the answer the negative sign. So that's one thing we see. The other thing we see is when the signs are different. When the signs are different, like one is positive and one is negative, we subtract the numbers, and then we give the answer the sign of the bigger number. So for example, looking at the box in the bottom in green, that's when the signs are the same. So 5 and 6 are both positive, so we add 5 and 6 and get 11. Or if we have negative 3 plus negative 4, the signs are the same, they're both negative. So I add 3 plus 4 and I get 7, and then I slap on the negative sign because that's the common sign. When the signs are different, the process is a little bit different. When we see that addition sign and the signs are different, so we see 2 is positive and 4 is negative, that really means to subtract them. So I take 4 minus 2, I put the bigger number first in subtraction, and I find that it's 2. But then to pick what sign the answer will have, I look at which one of those numbers is bigger. 4 is bigger, and 4 was initially negative, so my final answer will be negative. So I get negative 2. To summarize, like when we're adding numbers, a way to remember is when the signs are the same, you keep it all the same. If you're in positive, you stay in positive. If you're in negative, you stay in negative. That one's the more straightforward one. But in blue, when the signs are different, that's really telling us to find their difference. Difference is a keyword to subtract. So every time we see an addition problem with the signs when the signs are different, we are actually going to turn that into a subtraction problem. The reason I wanted to start with this review is because if we know how to add positive and negative numbers, then we can subtract positive and negative numbers with just one more step. And that's true because we can turn any subtraction problem into an addition problem. And if we can turn any subtraction problem into an addition problem, then we can solve any subtraction problem. And the way we do this is a strategy called keep, change, change, which you see here. In this strategy, you might be given a subtraction problem with positive and negative numbers, like you see in the top line. And the strategy is keep, change, change. So the first number we keep, the 12, we keep the same as 12 goes to 12. Change is about the sign. We change subtraction to addition. And then change, again, we change the sign of the second number. So negative 6 becomes positive 6. So now what was originally a subtraction problem is now an addition problem, and it's just 12 plus 6 equals 18. This subtraction and these addition problems are equivalent. They're the same as long as we do all 3 steps. So we can't just change one of these. We have to change both signs of the subtraction sign and of the second number. We're going to look at a couple examples of this next. So we could get a problem like this. That's 9 minus positive 3. And I see this is a subtraction problem. So my strategy is going to be to change it to addition. And I'm going to use keep, change, change to do that. Where I keep 9 as 9, I keep the first number the same. I change my sign from subtraction to addition. And I change the sign of my second number. I see in the first problem it was addition. So in the equivalent problem, it's now going to be a negative sign. And now I have 9 plus negative 3. The signs are different, so I'm going to find their difference. In other words, I'll do 9 minus 3. And then because 9 is the bigger number and it's positive, my final answer is 6. And that is keep, change, change. We're just going to see a few more examples of it. But look at the pattern every time of keeping the first number the same, changing the sign from subtraction to addition, and changing the sign of the second number. So in this problem, it asks us to subtract negative 4 from 7. This means I'm going to start at 7 and I will subtract -4. I see a subtraction problem, so I can change it to an addition problem. Same thing, I kept the first number the same, 7 stayed as 7. I changed the sign from subtraction to addition, and I changed the sign of the second number. It was originally negative, so it became positive. So 7 minus -4 is really 7 plus 4, which equals 11. Here's another example. I have 8 minus -2. I'm going to use keep, change to keep the first thing and change the next two. And I simplify that to 8 plus 2, which equals 10. So what we see here is in this pattern, subtracting a number is the same as adding its negative. So the negative of -2 is actually a positive 2. And again, we'll see I have -9 minus 3. It's subtraction, so I can use keep, change. The first number stays the same as negative. I flip the sign or change the sign from subtraction to addition, and I change the sign of the second number from 3 to -3. In other words, subtracting 3 is the same as adding -3. Now I have -9 plus -3. This sign is the same, so I just add them and then slap on a negative number. Here's another one, -4 minus -3. I kept -4 as 4. I changed subtraction to addition, and I changed -3 to +3. I can get rid of those parentheses, you notice, because I don't have to add a positive sign in front of that 3 anymore, so the parentheses also went away. Now I have -4 plus 3. The signs are different, so that's telling me to find their difference. In other words, I do 4 minus 3, that's where the 1 came from. And then because 4 is the bigger number and it's negative, I get -1. And one more example of this strategy, I have -1 minus 5. I keep -1, the first number the same. I change the sign from negative to positive, and I change the sign of the second number. Originally it was +5, and I made it -5. You'll notice I slapped on those parentheses to remind myself that that minus sign belongs to the 5. In other words, subtracting 5 is the same as adding -5, and I get -6. You notice here sometimes in problems with subtraction and negative numbers, we ask ourselves, wait, is that a subtraction sign or a negative sign? And this problem shows us that those are really the same thing. In the first line, we see this sign right in the middle as a subtraction sign. We read that as -1 minus 5. But we can also think about it as an addition sign if we make the 5 negative. That's what we see in the second line. It's -1 plus -5. So there really isn't a difference. It just depends on how we look at it. And we want to look at problems through addition because we already know how to add positive and negative numbers. Now, lastly, if we can do it in problems like this, we're also going to be asked to see it in word problems, and you're going to see that on your tests. And in these problems, when we see subtraction in word problems, we're still going to want to use the keep, change strategy to turn any subtraction problem into addition. So our first step in these problems will be to write a subtraction expression from the word problem. And we'll see some examples where we're going to look for keywords that tell us we should be subtracting. And then once we have the subtraction problem, you can use keep, change to solve any subtraction problem by writing it as an addition problem. We're going to look at 2 examples of that. So this problem reads, at 9 p.m., the temperature in Chicago was -6 degrees Fahrenheit. By morning, the temperature was 7 degrees Fahrenheit. How many degrees did the temperature rise overnight? One more time. At 9 p.m., the temperature in Chicago was -6 degrees Fahrenheit. By morning, the temperature was 7 degrees Fahrenheit. How many degrees did the temperature rise overnight? So I'm looking for a change here from that nighttime to the morning. And to do that, I'm going to look at this in terms of the number line I have on the side that's vertical, so it looks like a thermometer. And I see at 9 p.m., I started at -6 degrees Fahrenheit, so I'm going to draw an arrow down to -6 degrees Fahrenheit. But by morning, the temperature rose to 7 degrees Fahrenheit. So that purple arrow shows the change from 9 p.m. to the morning. And if you look at the purple arrow, you see the difference between the night temperature and the morning temperature. I just said the word difference, which signals an alarm in our head that difference tells us to subtract. So that means this is a subtraction problem. I'm going to show us how to solve this in subtraction, in terms of a subtraction problem. But right now you could see maybe how I could solve this on just a number line. And what I'm saying is on this number line, my purple arrow represents how many degrees the temperature rose overnight. So you could draw a number line from this problem and count how long my purple arrow is. You can do it on a number line, and you can also do it in a subtraction expression. If I want to find the difference, I want to subtract what I started with from where I finished. Well, I finished, the temperature was at 7 degrees. And I want to find the difference between subtraction, so I'm going to subtract -6. In front of me, I see a subtraction problem with positive and negative numbers. So I'm going to use keep, change, where I keep the first number the same, I change subtraction to addition, and I change the sign of my second number from negative to positive. So 7 minus -6 really means 7 plus 6, and I get 13. If you notice over here on the right side of the page, if you counted the number of spaces on my purple line, you would also get 13. So these are both good ways of solving the problem. In this problem, because the numbers are smaller, the number line might have been an easier way to choose it because you could count the spaces. But sometimes we have problems that may have numbers too big for a number line, which is why writing them as subtraction problems is another helpful skill. And here's one of those problems with a bit bigger of numbers. This problem says, Mount McKinley in Alaska, the highest mountain in North America, is 20,320 feet above sea level. Death Valley, the lowest point, is 280 feet below sea level. What is the difference in height between Mount McKinley and Death Valley? So I just read that one time, and my first time reading it, I was really just thinking about it generally. I wasn't really reading for anything specific. I'm going to read the problem one more time, but this time I'm going to see if I can pick out some keywords. Mount McKinley in Alaska, the highest mountain in North America, is 20,320 feet above sea level. Death Valley, the lowest point, is 280 feet below sea level. What is the difference in height between Mount McKinley and Death Valley? When I just read that the second time, there were 3 keywords that stuck out to me. The first word was this word above in the second line, and it tells me that that highest point is above sea level. I'm going to think about sea level as my point 0 and above sea level as positive, which tells me that this 20,320 is positive. Then the second point I saw was the word below. And the below referred to 280, and it said the lowest point is 280 feet below sea level. If we're below sea level, that is a keyword telling me that 280 is a negative value. So I'm going to assign 280 as negative. The last word that stuck out to me was difference. I want to find the difference between their heights. Well, difference is a keyword telling me to subtract. So I'm going to take away or subtract the smallest number from the biggest number. Now I have a subtraction problem with positive and negative numbers, and I know that that was doing step 1 in my word problems. I turned those 3 different confusing sentences into a simple subtraction problem with bigger numbers, but one that I can still solve by using keep, change. It's a subtraction problem, so I'm going to turn it into addition by keeping the first number the same, by changing subtraction to addition, and by changing the second number that was negative into a positive number. Then I see that that subtraction problem is really just an addition problem. I can add 20,320 with 280, and I get 20,600, and I should really say that's 20,600 feet because we were talking about beat. So that is all, that's our strategy for subtracting negative numbers. The big takeaway is that we want to turn every subtraction problem we see into addition, and then we can use the strategies that you already have to add positive and negative numbers.